You spent weeks building something epic, like this Burj Al Arab made out of matchsticks.
Ta-da! The Burj Al Arab, all built with matchsticks.
But now, you need the world to see it.
Let's see how it looks on the video.
When you hit
my
post,
latest build with
you don't
the
want to
world.
view at a time. You're looking for exponential growth. If one person shares it with 2 friends, and they share it with 2 more, that's 2 to the power 1, 2 to the power 2, 2 to the power 3. Within 20 steps, you've reached over 1 million people. When the exponent grows, the result doesn't just increase, it explodes. This is how a toothpick tower becomes a global trend. So, next time you see indices in class, don't just solve them. Use them to go viral. Because the difference between a post and a phenomenon is just a bit of algebra. So what? Now you know.
Today in this video, we are going to be solving questions related to the 4th subtopic, indices of the topic algebra and graphs. So indices is a very short subtopic. It can be understood in less than 5 minutes. So you'll be able to get it and never to fail a number that has the concept of indices. Let me first give you a brief intro about indices, and then we'll be able to do a few numbers, maybe 1 or 2 of these, so that you can proceed in your time and you do all the rest. So when you think about indices, think about numbers that have powers. So powers can be negative, powers can be positive, and then those numbers will be operated. So operations can depend. It can be addition, can be subtraction, division, or multiplication. So we are going to do the introduction on all of them, and then we'll be able to solve a few numbers and we'll be good to go. For example, in indices, if we have, let's say, a power 2 plus a power 3, I hope you're able to see that there is a pattern among these two numbers, between these two numbers that are written. These two numbers have the same base. If this is a and this is a, then that's an indication that you're dealing with indices. If this is a and this is b, no. But if the bases are the same, and then it means this is indices. And under indices, if we have the same bases and we are adding, then we are going to multiply the powers. In fact, let me use numbers that do not have, let me use x power a plus x power b. So once the base is the same as x, then it means we are going to have a power a times b. So if the bases are the same and we are adding, then we multiply the powers. And if the bases are the same and we are multiplying, so we've already seen when adding, we multiply the powers, meaning when we are multiplying, then we are going to add the powers. I hope that is very clear. Then let's go to division and subtraction. Let's still x power a minus x power b. So if the bases are the same and we subtract, then you write one base and then you divide the powers. And lastly, if the bases are the same and you are dividing, then you will subtract the powers. That's the rule. Same bases, added, multiply the powers, divided, subtract the powers, subtracted, divide the powers, and multiplied, add the powers. Alright, so let's head into the real application, do a few numbers and see how we go.